Okay, so we're going to talk about kind of the road to the White House when it comes to Obama for America and technology, and we're going to talk about how Obama for America used Puppet and AWS. So first of all, what was OFA Tech? Who built it? Who was it? Who was part of the team? How did they do it? How did they do it differently from previous campaign teams? And what services and software did they leverage? And how did they use Puppet, most importantly for everyone here, right? And what did everyone who was on the campaign, what did they learn from it? Because when you build something so big, when you run things at scale, you learn things that you otherwise wouldn't have figured out. So first of all, I'm Leo. I now work for Amazon Web Services. I'm a senior solutions architect on the state, local, and education team. So if you're in state government, local government, or at a university, and you need help architecting your solution on AWS, you probably talk to me or one of my colleagues. I used to work for the Democratic National Committee. I started about a year after the 2008 election in 2009, and I kept working all the way through this presidential election until the end of 2012. And so as soon as the Obama for America campaign started, I kind of became embedded in it. So by the last 3 months, I was there the whole time, and we worked very closely with OFA. And just to make clear, Amazon Web Services does not endorse political candidates. I was an employee at the DNC at the time, and so this is strictly nonpartisan talk about the technology that OFA used. And a fun fact about me, I love Star Trek. I've seen probably every episode of Star Trek ever, and I name my personal laptops and devices after Klingon battleships. So here's the idea before we started the campaign of what we wanted to do. We knew that all told, when it comes to our store, and more importantly, our donation platform, we were going to be about the 30th biggest e-commerce operation globally. We had by the end of the campaign, about a little bit over 200 distinct applications. Many of them were mobile. They were written in all kinds of different languages. And we had a big analytics team. They were doing a lot of untested approaches that had never been tried before. And they were processing hundreds of terabytes of data on thousands of servers. And our traffic patterns were very spiky. On a regular day, on most of our websites, we wouldn't get that much traffic, but then something would happen. The president would say something on network television, or we'd tweet something out, or we'd send an email blast to millions of people, and our traffic would spike a lot. So we needed to, so that's all, stuff that's kind of an interesting and fun thing to solve. We had some constraints, though. So this is the not fun part of it. So we kind of had champagne requirements on a beer budget. We couldn't have gone out and bought a bunch of servers, especially at the beginning of a campaign before the fundraising really starts. You don't have a lot of capital expenses. And we also really only had less than a year to execute. We had about 1.8 years for the whole campaign. But if you count what actually, when the primaries are going on and all that, when the actual campaign season is going on, that's only about less than a year. All of our development team was either volunteer or close to volunteer. They had to, a lot of them had to give up their jobs and move from the West Coast and a bunch of other places to Chicago. That's where the campaign was headquartered. So it was a challenge, for them. And also, we didn't really, everything had to work on election day. If it didn't work on November 6th, 2012, then, it didn't work. There was no second chance. And like I said, the election day was constitutionally mandated, so we really had to stick to deadlines here. So this is a picture of our campaign team. There's about 40 developers and about 5 DevOps people. And these folks came from all over the place, different companies here in the San Francisco Bay Area, but also Chicago, really all over the place. And they were some of the best and brightest people I've ever worked with. So this is what it looked like at the campaign. Kind of looked like any other startup, at least on the tech side. We had a lot of banners. We had a lot of Nerf guns. We basically lived there. It was crowded. You didn't get much personal space. So business as usual for a tech startup. This is a picture from election day. There's Harper. There's Eric Schmidt. He was volunteering for us for a little bit. So it was a cool experience. We had to build all these things, and they all had to work. And it was a wide range of things. And then we won, so it worked. So how did we do that? So this is just an example of our basic traffic pattern. This was the chart from our call tool. So it starts at about July of 2012, and then it ends right at election day. So the last day on the call tool, we made about 1 million calls. So everything really had to be architected to scale to begin with. This was a tweet after the election from the head DevOps person, Scott Vandenplas, kind of about what the stats were on some of these things. So it was really hard stuff to do. So how do we do it? So the classic approach would have been this, right? You just buy servers, right? You buy them from Amazon, from anywhere else. The problem is this approach doesn't really scale. So the OFA headquarters in Chicago didn't really have a lot of room for servers. If you're on a very short timeline, you can't really wait a month for a server to arrive. So we had to be able to scale fast. So we thought about it, and we decided that cloud computing is the way we should go. So there's no upfront capital expenses, obviously, right? And that's big for a campaign because, like I said, in the first few months of a campaign, you're not raising that much money, so you don't have a lot of money to just buy servers. And with AWS, you could just get started right away. It's low cost. You pay for exactly for what you use. So at the beginning of the campaign, the scale for most things isn't that big. So you just develop, and you have not that many instances, and so you're not paying for all this excess capacity. And it's also self-service. We didn't have to call anyone to spin up a server or an instance. We just did it through the APIs and all that. And we could also scale up and down easily and automatically. And this was big. We had a small staff, so we needed to be able to do that. And we were able to also experiment, right? So like I said, we had about 200 apps. Some of them failed, but that was fine because we didn't buy any resources for them. We just, we had an idea, we tried it out, it didn't work, we shelved it, it worked, we scaled it. So it was a really good usage pattern. So if you want to find out more about our infrastructure, we actually have a website up. It's awsofa.info. And you can zoom in and take a look at like our auto-scaling groups, and it's pretty detailed. And there's some Easter eggs in there. We really liked Take 5 candy bars, so if you zoom in far enough on a certain part of it, they're in there. There's a bunch of other stuff, so have fun with that. So here's some of the things that we had to build, right? We had to build a lot of web scale applications. If www.barackobama.com is down, it's going to get mentioned in the news. It's bad press, right? So we couldn't have it go down. So we had to architect it to not go down. And we also had a payments processor. And taking donations or processing donations for a campaign is one of the most important things that a campaign's tech operation does. So this had to scale as well. And we also had a lot of big analytics systems. So we were using DynamoDB, and some of our DynamoDB tables had about 400,000 write capacity units on them. We had a big Vertica analytics cluster, and that one had a bunch of provisioned IOPS volumes. So there's about 8 nodes, and each of them had like 10 or more, I think, volumes with like 3,000 or 2,000 IOPS RAID zeroed across them. So we needed some big systems. We also we used SOA, so all of our services talk to each other through APIs. So what that meant is that they could be written in any language really because they talk to each other through APIs, and they could each independently scale up or down. So people ask me a lot, what languages or what operating systems, what monitoring tools did you use? We used a lot of stuff. We basically used everything that we could get our hands on. So for data stores, we used Postgres for some things. We used Mongo for other things. We used RDS. We used Vertica. We really didn't try to push a square peg into a round hole. We let our developers do what was right for the given project. Again, for development frameworks, we had some developers that were good at Ruby. We had some developers that were good at Python. So we just let them, we enabled them to use whatever they were comfortable with. So, and then for infrastructure, for configuration management and monitoring, we used a bunch of tools too. We used Puppet for actual configuration management. Yeah, so it worked out really well in that we weren't ideologically locked into using one thing or another. So let's talk about our Puppet use specifically, right? So it was mid-2011, and we were looking at what should we do for configuration management, and we looked at all the options, and we thought that Puppet was the best one at the time, and so we decided to use it. And then we had to figure out how do we scale it, right? So we knew that we would eventually have a really big infrastructure, and we knew that we were going to make it kind of stateless and horizontally scalable, so using auto-scale groups. So how do we get Puppet to work with that? So the first thing that that's kind of useful to keep in mind is how do you want to bootstrap it? There's multiple ways. You could have a pre-built image, or you could have a base image, right? So we used base images of Ubuntu that literally were stock that you could spin up in any AWS region, and then we bootstrapped Puppet onto them. Now, in AWS, there's a user data field. So you can basically, what that is when you launch an instance, you can give it a little shell script or a PowerShell script if you're in Windows, and you use that to bootstrap the instance. So you could do that. You could have just a bash script that spins it up. But it also supports, for Ubuntu and Amazon Linux, Cloud Init. So Cloud Init is just a YAML format init file that bootstraps your instance, so it's a little bit cleaner. So that's what we did. So as you can see in the example I have on the screen, it just installs the Puppet Labs repos, and it installs Git and S3CMD and the Puppet package, and so you're pretty much, it'll bootstrap Puppet for you on a base image. So the other thing is now you don't want to store creds in your Puppet manifest, or at least we didn't want to. So we store them in private S3 buckets. So there's two ways to then use that, right? So when your instance spins up, you want it to have access to these S3 buckets. So you either on boot you just insert those creds, right, and then you just have S3CMD read those, or this came out about halfway through the campaign, is in Amazon IAM, you could have IAM roles. So your instance has a role that has privileges attached to it, such as read access to an S3 bucket. So you basically just, when you launch the instance, you give it that IAM role, and then you don't have to do what I did above. So it'll just have access to that S3 bucket. And the other cool thing about Cloud Init is it has built-in Puppet support. So you can, basically that just gets translated into the Puppet master config file. And so that's what you do for that. Now, how do you, when you're scaling up and you're scaling down and you have instances that come in and out of service all the time, how do you handle that? So what we did was we decided to have auto sign turned on, so anything that talked to the Puppet masters would get accepted if it had the right node name. And the node name was going off of the cert name. So we would have the function of whatever the instance was, and then we'd have a unique key just for security. And then we would, after that, we'd insert the instance ID, right? And we tell it to talk to the Puppet master. And so as a result, what you have to do is you have to be careful with your security groups or your network access control lists so that you want to control what talks to your Puppet masters. If you're using a VPC, a virtual private cloud in Amazon, then you can have an internal load balancer in front of your Puppet masters, so it's a lot easier then. And so then what you do is in your nodes.pp file, you use a regex to just match the node names to that cert name. And so that's how your Puppet master knows what to install on those nodes. So then the next thing you want to do is you want to have a base class to define your standard install, obviously, right? So this is something that gets installed on every single instance. Then you want to use run stages, and this is really helpful. So all the cred installation, all the repos, all that kind of stuff should get run before it actually installs your apps and it starts installing stuff, because if the repos aren't there and it tries to install things, it obviously won't work. So we had a prep run stage where it would do all that stuff, and we had a prep 2 run stage where it would do other stuff. And again, don't store your credentials in Puppet. Store things in private S3 buckets. So what we found worked best for us, we used Puppet for storing config files. We didn't store any kind of big files on it, right? So basically, for things that are unique about that app or on that instance, that's what you want to store in Puppet. So if it's undifferentiated, though, just use a RPM package or a Debian package. And what we found worked best for us, we didn't want to kind of maintain a separate instance for hosting the packages because it's kind of, it's more management, so we'd have to put it behind a load balancer and run a bunch of them and kind of monitor all that. So, instead of what we did was we just hosted them on S3 buckets. And so you can have it on a public S3 bucket that just supports, static hosting natively. So that's a really easy way to go about it. But if you have private packages, there's actually plugins for both RPM and Debian packages that allow you to host your packages on private S3 buckets, and then you just either give it your S3 credentials in the yum.repos.conf file or in the apt config file, or there's other plugins out there that just use the IAM role, so you don't have to give it S3 creds. And S3 is really scalable. It's got 11 nines of durability, so we didn't really have to worry about scaling our package repos. The other thing that we did was we basically almost always had ensure latest on all of our packages. So our nodes would just automatically install whatever the latest thing in the repo was, and we basically just rolled forward. We didn't ever really roll back, so if there's a problem, we just release a new version of a package. And we found that worked pretty good for us, and we didn't even have to update the manifests when we bumped the package. The other thing is we also logged everything, right? You want to know what's going on. So we used Graylog, we used rsyslog, we used Loggly, and we used New Relic for the actual application level monitoring, and we Splunk for some things. So you just want to, when you're doing deploys, you want to know what's going on. For example, in New Relic, there's a feature that when you do an app deploy, it gets marked in New Relic, and then you could see the speed on different pages before and after. So we found that to be really useful. And so one of the things we monitored was the actual Puppet master. So the other thing is, scaling the Puppet masters. That can be a single point of failure, obviously. So how do we do that? So we had an auto-scaling group, basically, of our Puppet masters. And it had a minimum size of 2. So there was always at least 2 of them. They were in multiple availability zones. And there's 2 ways that we found that you could have them bootstrap themselves. What we did was we always kind of assumed that there would be one Puppet master in service. So we had Puppet master could build itself off the existing Puppet masters. And that was a kind of it worked pretty well. But if you're worried about all of your Puppet masters not being available, what you could do is just have the bootstrap for the Puppet masters be different than everything else. Have it bootstrap off of a copy of your manifest in S3. And so then it doesn't depend on the Puppet master itself being up. And again, you want to have auto signing on because you can't manually approve nodes. So what did we build with this? We had all kinds of stuff that was running on Puppet. We had different websites. We had communications tools. We had ops tools. Like I said, there was analytics databases. All kinds of stuff. Reporting. We had tools that monitored our volunteers and how they were engaged. We had voter registration sites that allowed anyone to basically to register to vote. And it was all controlled by Puppet. So we made a bunch of choices. And with those choices, there's the common it's commonly thought that there's trade-offs, right? So we chose to do polyglot development. We, like I said, used every single language that our developers wanted us to, basically. We used AWS. We didn't have one monolithic database. We had a bunch of, each app would basically have its own database if it needed, and what the database was dependent on what the app was. And we used a lot of queues, right, and SOA. So there's some expected trade-offs to that, but what we actually found is our choices worked out really well. By doing polyglot development, we were able to build things really fast, right? And our developers just reused the skills they already had. They didn't have to learn new languages. By using AWS, we were able to build things to scale beyond anything we could have done on-premise. And we made things really fast and cost-effective. like I said, we only paid for what we used. So we'd scale up a lot, but we'd also scale down when we didn't have traffic on our apps. And then for the databases, we chose the right tool for the right job. So we didn't have to force apps to use a database that they weren't perhaps optimized for. And then using queues, that also helped a lot because it allowed us to scale a lot easier. So the queues were like the glue in between services. And I'll tell you a story later on about how SQS kind of saved us one time. So let's talk about scale of Amazon Web Services, right? So in 2003, Amazon.com was around a $5 billion retail business. It had a whole lot of servers, right? So every day in 2012, AWS adds enough capacity to power that whole $5 billion enterprise every day. Now SQS, which is actually SQS, a simple queuing service, it was the first Amazon Web Service service. Not a lot of people know that. So it came before EC2 and S3. So in 2006 through 2008, there's over 5 billion queued events using that service. At Obama for America, we used about 8.4 billion queued events in the last month of the campaign. So we heavily used queues. So like a lot of things on AWS, you could either use the service, you could use SQS, or you could build your own queue. It's really up to you. But we determined that it was a lot easier for us to just use existing services where we could. So it costs 1 cent per 10,000 requests for SQS, and it costs 8 cents per hour to run a small instance. But not only that, you have to think about scale. If you have 8.4 billion queue messages in a month, you can't just run it on one instance. You're going to have to run a lot of instances, so it's going to cost more than 8 cents per hour. So, and we didn't really have time to waste. Like I said, we had to be done and all up and running on election day and other important events during the election. So this can be applied to a lot of different services, right? You can run your own load balancer. You can run your own cache, your own databases, your own DNS, your own storage. But do you really want to? So you have to examine if it's worth the time and the investment in it when you can just use something that's already built for that and is scalable. So for example, with DynamoDB, right, we were able to insert 7.5 million records in 8 minutes. To build a system that does that would take a lot of effort on your own. So another thing that's kind of I would say it was difficult to prepare for was kind of our RDR strategy, right? This is the wind map of Hurricane Sandy. And Hurricane Sandy happened about 3 weeks before the election. So at the time, all of our stuff was on the US East region, and the stuff that was on-prem at the DNC was also in the general Virginia area. So that was right where the hurricane was headed. So we were a little bit worried. And somebody got us this cake, so we got a lot of support from our higher-ups, emotional support on that. And funny story about this cake was when they got it, so it sat there on our desk for like a week because they thought that the message was about the cake, so nobody wanted to cut into the cake. So eventually somebody did, but I kind of feel bad for them because they ate a week-old piece of cake that was unrefrigerated. So we basically the last 3 months of the election, we had built up this part of our infrastructure, right? It was already built and it just scaled up and down differently. So it took us 9 hours to replicate that all to the West Coast. Now it wasn't scaled up as much in terms of the sizes of the auto-scale groups and stuff, but we were able to use Puppet and just AWS APIs, and we used Asgard a lot actually to pre-package our AMIs at that point, and CloudOp to transfer the data. And so we basically had cross-continent fault tolerance on demand. Now, how did we do it in 9 hours besides this was we had a lot of caffeine. Those energy shots, I wouldn't recommend those, but everything else in that cabinet's pretty good. So we also, it's important to have like a perimeter defense around your DevOps corner with lots of Nerf guns, because you don't, when you're moving lots of stuff over, you want to be able to work. So another thing is, we found the challenge was really recreating your auto-scale groups and security groups and all that stuff in another region is pretty easy. The challenge was copying the data. Because we had, for one of our databases, we had 27 terabytes of data, and we had to get that from the East Coast to the West Coast. So we used Tsunami UDP, and we had it on 4 CC2 8XL instances, and it took us only about 3.92 hours to move that. So that was fast, and that was a lot of fun. You also find out the limits of your on-prem routers and stuff if you're blasting that much UDP traffic. But you should check out Tsunami UDP. It's a great tool for copying a lot of data. It's pretty easy to set up too. So basically, what did we learn? So the one thing is we learned to make things as simple as possible. So if you've got a site that's just completely static, don't even bother to put it on instances. Just host it off of S3. It took me about 30 minutes to set up a full site, from buying the domain to giving the front-end developers access to the S3 bucket and all that. So I'd set up a site, and we had a lot of microsites. We came up with several a week usually, and most of the time they didn't go anywhere. No one used them. But this one time, they had me make this microsite. It was called RomneyTaxPlan.com, and it was kind of just a layout of a button that says click here to view Romney's tax plan, and when you clicked on the button, it would run around and you'd never be able to click on it. And so it went viral. It was #1 on Reddit. And so I remember I woke up that day and I checked Reddit, and I'm like, oh, that's my site that's on Reddit. That's #1. But it was hosted on an S3 bucket, and it had a CloudFront in front of it, so it was completely cached, and it was doing about 17,000 concurrent users at the same time, and no problem. It just worked. Another thing that we did was we used Jekyll for static sites. That it helps you build them a lot faster. And so the other thing that was really important is we did something called Game Day. And he was the director of engineering at OFA. He did a talk at VelocityConf on this. His name is Dylan Richard. So basically what we did was, a few weeks before the election, maybe a month before the election, one weekend we decided to break all of our stuff in staging. So the DevOps team, their job was just to sit there and say, okay, we're going to mess up these security groups. We're going to stop the app from talking to the database just to see what happens. And then so they would mess something up, and then developers would have to figure out either how to fix it or how to get it to fail gracefully. So that turned out to be really useful. It really taught us more to do loose coupling between all of our services and our application tiers. So during the vice presidential debate, what happened was we were getting a lot of donations on our donation processing system. It must have been millions of dollars an hour. And then our DBA discovered that our RDS MySQL instance was undersized, that it was basically going to full CPU load, and we had to upsize it, or else it was going to go down. So, and this was our fault. We just didn't size it properly. We didn't do what we ended up doing was we actually had an SQS queue in front of it. So the donations would come in, they'd go on the queue, a worker would take them off the queue and process them and put them in the database. So we'd actually practiced this on game day. So we resized the database live during the debate. It rebooted, it resized to a bigger database, it came back up, the queue cleared out, and nobody noticed we didn't lose one donation. So it's that kind of stuff that, that's when we felt like we architected things properly. Fail fast and fail forward. So instead of being afraid of failure, if you're running things at scale, you just have to learn how to fail really fast. So like I said, we wouldn't roll anything back. If something was broken, we'd release another version of the app and just update it. And we learned that for us, the cloud really worked. We were super happy with AWS. It allowed us to do things that would have been really, really hard to do in on-premises environments. So then after the election was over, the first thing we did was we showed it, this whole architecture at last year's reInvent, which was the yearly Amazon Web Services conference. There's going to be one this year in November. And we put it across 3 giant screens, and so that was fun. And we did a panel with our whole DevOps crew on how to do that. And And then we presented it in Tokyo. That's Harper, the CTO. And we've had a lot of services or a lot of startups that have come out of it. So the campaign transitioned into organizing for action, which there's a bunch of stuff now. So there's been a bunch of startups that have started, and it's exciting to see all the stuff that's developing from the campaign. So what should you do now that you know this knowledge? You should look at some of our source code. The DNC released their voter registration tool on GitHub, so you can go and look at it and get your own copy. It's interesting, and it's really cool code. And you should go to reInvent, which is our conference. There's a $200 discount code on there. So we're going to have a bunch of deep dive workshops and technical sessions, and you can learn a lot over there. And so thank you. And if you have any questions, just come see me at table 22 by the vendor booths, or follow me on Twitter, or email me. And also at our booth, we have a bunch of AWS credits that we're giving out. So come stop by our booth. All right, thank you.